Good morning, everyone. Hello, can you
Good
hear me?
morning, doctor.
How are you?
I'm fine. How are you?
I'm good. So, 8 students joined, and I think I should have at least 20 students. So, how are you all?
I'm fine.
So, how was 101? You guys take this subject after 101, right?
No,
No, okay.
I waited some courses.
Okay. So, this course is electronic instrumentation. So let me share, first of all, I will introduce myself, but let me share my slides to you. Can you see my screen?
Yes, we can.
Okay. So my name is Madiha Safdar, and I am your course instructor for this lab activities. And so this lab activity is, I have distributed the marks like this, that 10% will be the marks of your lab reports and 5% will be the grade of your final lab exam. So total it will be 15%. And then you will have pre-lab, and then pre-lab marks distribution will be, just a minute, let me try to start my pen. So it doesn't work. Okay. So anyway, okay. So this I will annotate here. So I will give you 2 marks when you have already done your pre-lab. Okay. When you will come for the for your lab activity, then you should bring your hard copy, printed version of the lab with the solved pre-lab. Okay. So that we will this lab will be all of it will be hardware. So you will make your circuits before coming to the lab, and then I will tell you how to make the circuit. I will tell you how to download the software, everything. Today we will do all these things, so that next lab you will come with your pre-lab. Okay. So then the students who will participate in the class, who will perform the experiment, who will do all the simulation work from home, and then in the class they will do all the hardware with me, then they will get 4 marks. Here it's written. So let me see, my cursor is not. So yes, can you see this red dot?
Yes, we can.
Yes. Okay. So these 2 marks are for the pre-lab, right? So then class participation 4 marks, and then lab report submission 4 marks. Okay. So the students who will not be able to perform the experiment in the lab and who are absent, they will get 0 for this. Okay. So their lab report will be graded out of 6 marks, 4 plus 2. Okay. So class participation is very important so that you will learn, right? Then when you are done with your lab report, you will submit your lab report in the Moodle. I will post a link on the Moodle for the lab report submission. And then you will post your lab report there within the due date. Okay. And then I will give you 3 days for the lab report submission. Okay. If you will submit the lab report within that time, it will be okay. Otherwise, if you are late, then there will be deduction of marks. Okay. So I will give you my email address for the if you need some emergency contact with me, but I will not accept any lab report submission by email. Okay. Then don't submit your lab report late, because it will be accepted, but then I will deduct some marks. Then if you don't participate during the lab, then there will be no lab activity marks. Which are the lab activity marks? These 4 marks. You will lose these 4 marks if you don't participate in the class. Then if you
participate, doctor, doesn't mean solving questions, right?
yes, exactly. Participation means solving the question. So, not question, solving the lab experiment, because this lab will be based on hardware. I will tell you how we will perform the experiment in the lab. I will guide you in everything. But at the end, I need a very good report. I need very high participation from you people, and I need always your pre-lab to be done before coming to the lab. Okay, I will tell you what is pre-lab. I will tell you all these things. So that three things I want from you: class participation, pre-lab, and then submission of the report in a good manner according to the format. Okay. So then, if you're then I will divide you guys into groups. So 4 members per group. Okay. I will post the group selection on the Moodle. You can choose your groups yourself, and then 4 people in one group. Okay. And then I will also post the format of the lab report in Moodle. So you will have to write objective, introduction, and the lab itself, results, and then conclusion. I will post that format template on the Moodle, and then you will be able to do that. So 4 people, so you will distribute your lab report among you. Some students can write the introduction, some students can write the results, some students can write the conclusion. So collectively you will learn the teamwork, and also you will learn how to write a technical report. Okay, this will be very good for you. So then this is the multi-sim environment. This software we will use for our simulation work. Are you guys familiar with multi-sim environment?
No.
No. Okay, so I will tell you what this is. Please, all of you, make your laptops ready with you so that we can download this software today. So this is the main page of this multi-sim software, and then here we will build our circuit, and then we will implement the same circuit in the hardware. Okay, when you will come to the lab next week. From the next week, all of you have to come to the lab. Okay, there will be no online session for the labs. Okay, all the labs will be in campus. I will not post any Zoom link for the labs because it will be in campus. All of you have to come to the campus. Okay. Then this is okay. Let's first do this, that try to download this software so that you guys have some idea about it. Okay, so if you go to the Moodle main page, can you see my Moodle page?
Yes.
Yes. So this one, if you go to the announcement, go down, and here, click this one. Click this, and then it will open here. Okay. Go to this link, click it. It will take you to this link, but let me first. Okay. So it will take you here in this link, right? So
Can I write the software name in
yes,
Google, and it will take me to the.
it's better if you do with this, because then you will create your own account, and then you can simultaneously use multisim online account, and then you can also use multisim offline account. I will prefer multisim offline account, but some people who have MacBook, they are not able to download this software in their laptops, so they will be using online account. But it's better if you click this one, it will take you here. From here, you will click this one, it will take you here on this page. Okay. The first step will be sign up. Okay, please all of you do this step with me, because from the next lab, I will not be able to teach you how to install the multisim. Please, all of you, please start to download this software. All of you, you are with me. So if students are not participating from the day one, so okay, first day is fine, but you should have this software when you will come to the lab.
Okay,
Okay.
I'm on the same page you are.
Okay. Then click this sign up. So follow this. You
I
will click.
did
Okay. Then you will have this kind of create an NI user account,
with
right?
my
Yes.
college ID, college email.
Yes. Here you will write your first name, then your last name, and then company will be KCST Kuwait College of Science and Technology. This
And
one.
what allies or
The LI is okay.
ALIA?
Okay. Let me do this with you. I already have an account. So this is your student ID. For example, you have your email ID with your KCST email ID is with some ID, your student ID. Write that student ID here. Okay. Is this? Yes, this is the same software, Arij, which you used for 101. If you guys already have this multi-sim software from 101 course, then you are good. You don't have to do anything. But the students who don't have
And role.
role is student.
Okay.
Yes, this one, student. And company is KCST. Just write, maybe it will give you KC.
Can
Yes.
I put engineer instead?
Okay. Okay, put engineer, but students is fine because you will be using your university account.
So I can.
Okay.
Okay.
Then KCST Kuwait College of Science and Technology. This one.
I don't see any student or something, doctor. It's engineer, engineering management,
There is,
programmer.
if you just go down, just
I do
scroll this.
scientist, and no, you have more than me, I think.
No, no,
Ah,
it's
okay, okay, I found it. I found it.
yeah. Just scroll this one down.
Yeah, I found it.
So all the students, please speak something so that I know that you guys are with me alive because I think
Miss,
you
I
are.
have the software downloaded.
Okay. Okay. So student, then your email ID.
There is two, doctor. There is KCST, the last thing Doha, and KCST, the last thing Kuwait, which is what I
Kuwait
choose.
is fine. Yes, yes. Because
Kuwait,
city Kuwait will come here. Yes.
school address. I have to write this the school address.
This is email address.
Ah, okay.
Your
Which
student
is?
email from KCST.
Ah,
Student,
okay.
yeah. Your student ID @ of student.kcst. Right here, some ID like this.
No, not email address. Address, the real address.
No, like this will come, right?
No, no, no. No, I can't find it in your screen.
Check this. Like this.
No, I have it before city, between city and school. I have school address.
Okay, just write Doha Road.
Okay.
Done?
No, not yet. I have to memorize my email.
Who else is downloading the software with me except Abdurrahman? Who else is downloading the software? All of you have the software? Because then I can download this software for Abdurrahman myself. Okay. Yes, Arij, you already have it.
No, no need for that, doctor. It's easy for download.
Okay. So then you have to confirm your email account from your KCST email ID. Okay, you will click that link. And then after that, you will download this software. All the steps are here. Okay. When your account is verified, then you will click this link to download the software. Okay, Abdurrahman? So that I can move forward, because I think only you are downloading the software. Then all the others, I assume that they have the software. So just follow these instructions. And if you still have problem, then you can ask me. When your account is verified, after that, you will click this link. Okay? All the instructions are here. Okay?
Okay, I'm continue to making it right now, but my email, you know, it's long, so I have to trying to not making mistakes.
Yes. Okay. So I should move forward.
Yes.
Okay. So then, so if any of you face problem, this is all the instructions are here. So then you can download this multi-sim software. Okay. When you are done with the multi-sim software, then you will, when you will double click the software, you will get this window. Okay. So this is here we will build our circuit. Then, so these are the components from here, from this icon. Abdurrahman, you can download the software later and then listen to my instructions now, because these are important for solving your pre-lab. Okay. So here, from here, you will bring the components. So for example, here resistor, then you will click this window, and then you will place the software, you will place the components on the multisim main window. Okay. Then saving, you will save it with with the name, and then .ms14. Okay. Then there should be no space, and then extension should be ms14. Then this is your first lab experiment. So here you have a variable voltage supply, and then you have a diode. Your first lab is to, let me now open your lab exercise. I will upload this lab activity on Moodle. So first lab exercise I will upload on Moodle, so that you can solve pre-lab yourself. So that when you come to the next lab, you have your pre-lab ready with you. Okay?
Yes.
Again, doctor, please.
So this is your first lab exercise. Okay? In this lab, we will check the characteristic of a diode. Do you know what is diode? What is diode? So let me start my pen, because just a moment. Wait, just a second.
This course is about diodes.
Yes, this, not this course, this first lab exercise is about diodes. Okay.
Okay.
So I will check if this works. Yeah, I need to charge my pen. Anyway, okay. I will tell you what is diode. Okay. So diode is a semiconductor device. Okay, it has two terminals, anode and cathode. Do you know what is anode and what is cathode? You have
Anode is the positive and cathode is the negative, I think.
negative. Yes. Yes, exactly. And the symbol is this, and then the actual device is this. Okay. So what it does is, for example, if you see here, I have put a diode here. So check this. So when the positive terminal is connected, this is the positive side of diode. Can you see my mouse?
Yes.
So this is the positive side of diode. This is the negative side of diode. You know that when, yes, when you will start, when the conduction will start, then current will flow like this, okay, across this diode, okay. So this is connected to the positive. This diode is in forward biased mode. It means that whenever positive side is connected with positive and negative with negative, it will conduct in forward mode. Okay. Then if you, for example, if I do this and then
it will be the opposite, the
it
reverse
will be,
mode.
yes, it will be reverse biased. So if I connect here and here, so now positive side is connected with the negative side is connected with the positive side. Then this will be a reverse bias mode. There will be no conduction from the diode during the reverse bias mode. It will block the flow of current during the reverse bias. So we can say diode is also one, because the diode allows only in one direction. So it is also known as unidirection device. It will allow the flow of current only during the forward bias mode. Okay, it will block the current during the reverse bias mode. Okay, so this is a diode. Then first let me okay, I will. So in this lab, the purpose of your lab is to check the forward and reverse bias characteristics of diode. So then there is another thing, that diode has a threshold voltage of 0.7 volt in case of silicon and 0.3 volt in case of germanium. So when that threshold voltage is achieved, then the conduction will start. Okay. And during the reverse bias mode, there is a reverse breakdown voltage. When that reverse breakdown voltage of the diode is achieved, then then current will start to increase from the diode exponentially, and there will be no more increase in the voltage. Okay, so there are two limits for the diode. In forward bias mode, there is a limit of 0.3 or 0.7 volt for silicon, 0.3 for germanium. After that, conduction will start and current will start to flow from the diode. In the reverse bias mode, when the breakdown voltage is achieved, after that current will rise exponentially from the diode. Okay, these two characteristics, is it clear to you?
Yeah.
Yeah, okay. Then if I go down, your lab activity. Yes. So here, this is the pre-lab. Okay. So in this pre-lab, we have two different circuits. So can anyone tell me what is the difference between these two circuits? These are similar or different? Tell me.
No, the one on the left is reverse.
It's forward actually.
See, positive side is connected with the positive side. Negative is connected with the negative. So this is forward biased. Okay.
Ah, okay.
See, this side is negative. me try that my pen works. Okay. This is negative side. This is positive side. Always remember. So, and then what, in which mode this is connected, this diode is connected? Check the terminal of supply and check the terminal of
Positive
diode.
with negative and negative with positive.
Yes, positive with negative, negative with positive. So this is reverse bias mode. It's written also here. Forward biasing and reverse biasing. Okay. So these instructions are here. First of all, open the multisim application and build the circuit as. So all of you, please open the multisim software and start building this network. Okay. So I have already built the network. Okay. So all of these things you know already how to get them, but only two things are different, this diode and then this variable power supply. Okay, so I will tell you how to get it. Go here. Can you see my screen? From here, first of all, power sources.
From where, doctor?
Just a minute. Here, this place source, this one. See my mouse?
Okay, yeah.
And then here, sources. From here, sources. And then signal current source. Okay?
Okay.
And then DC interactive current. So 1 minute. Yes. No, this is not the one. Signal voltage, because we are giving the voltage. DC interactive voltage, this one. We need this. Put it here. Check. So you need this one. DC interactive voltage. Go to signal voltage sources here. Signal voltage sources and DC interactive voltage. Okay, clear? This, please all of you do this work with me, because I will check your pre-lab in the next class so that we can start working on the hardware. If you will not come with this pre-lab, there will be 0 marks for you. Okay, because this is important. Then rest of the things you already know, how to bring the ground, how to bring the resistor. This already I teach you in 101 course. Then the next thing is, from here, go to diodes. This is diode. And here, write the number of diode. Which number? 1N 4007G. So this one. This diode we need. Okay. Then you will click OK, you will get this diode. Okay. Rest of the things you already know. Here, what is this? What is this meter? Can anyone tell me?
Voltmeter.
Multimeter. Multimeter.
Multimeter. So you will get this multimeter from here. See my mouse? From here you will get it. Okay. Now this is connected. This meter is connected in which manner? Can anyone tell me? Which manner this multimeter is connected?
In series.
Series. Very good. And then, so it means if it is connected in series, so which meter is this?
It is a meter.
Yes.
Current.
Yes, it is ammeter. So for current, from here you will click A. Okay. Now this meter is connected in which manner?
Parallel.
Parallel. Yes. Because this side is here. This side is here. So this I will select voltage. Okay.
Miss,
Yes.
can you repeat where you get the multimeter?
Okay. So here, see on the right side, this button.
Okay.
And then
thank
also you can see there's multimeter. Click this and it will come here.
Thank you.
Then you will connect this meter in series. Then you have to select A from here. When you connect this meter in parallel, you have to select voltage from here. Okay. Please all of you try to build this circuit. Done? Abdurrahman, your software downloaded or not?
No, I'm conforming my account, and I confused. How can I open the software? Because I didn't
You
download
confirm
anything
your
yet.
account? You confirmed your account?
Yeah, now
Okay.
I confirm.
Okay, so then please all of you take screenshot of this circuit so that I can show some steps to Abdurrahman. Okay, done? Okay, so Abdurrahman, you remember here this this page. Have you opened it?
Yes, I did.
So here, go to this link. Click this link. Click this link. This link.
Okay.
On page number 2. This will come here. Now here, download this.
Okay.
Okay. Then downloading will start and follow these steps. Okay.
Okay.
Done. Okay. And then
Done.
ask me if you have any problem, because then in the next lab I will check your pre-lab. So
I will be happy to show it to you.
yeah, inshallah. So all of you, are you done with this circuit? Should I move to the next step?
But how did you change the value of the variable voltage source?
Yes. Double click this. Okay. So maximum value choose 10, minimum value choose 0, and then choose an increment of 1%. 1%. Okay.
Thank you.
Done. Then from here, it's better if for more precision, just click this. There is a bar down this number, and then with your arrow key on the computer. So this arrow key, I'm not changing it with the mouse. With the arrow key, just click on the bar here, and then you can change the value with the key. So 1% I am changing the values. Okay. Clear? Like
Yes,
this.
miss.
With an increment of 1 with my arrow key. So first, now, if you go down, this table already I filled it, but we can delete it, and then from here, go back to your circuit, run the circuit, okay, and then double click this, okay. This is for the voltage, this is for the current, okay. For the 0, it's 0. Then you will come here, and then for 0, it is 0. This is the voltage across the diode. Okay, 1 minute, I show you again. Voltage across diode you will get here, and then current current across the diode you will get from here. Okay, so 0, 0 for the input voltage of 0. Then you will increase your voltage to 0.2. 0.2. Check this. This is changing now. This is 199 millivolt. It means 0.1 volt. Okay, 0.19 volt. Yes, Arish.
Miss, in the right multimeter, we choose the voltage.
Yes, this is the voltage across diode. When you will click this voltage, when you will connect, always remember the multimeter which is connected in parallel will always give you voltage. Okay, so you have to choose from here V. Okay, so if you choose A, it will give you wrong result because this is voltmeter. I need voltage. So this is important. From here you will check A. Okay, then So it means 0.2 millivolt is the voltage across the diode, and then the current is 498 nanoampere. So can anyone tell me? It means that I can say that the current across the diode is 0 ampere. That is true or not in this case? Because I have nanoampere is very, very less value. Let me try to write with my pen if I can.
Because we need to multiply it.
Yes, now it's writing. So check. Okay, so this is 498.726 nano means 10 raised to the power minus 9. So it means it's very, very less value, 0.0000123456498 ampere current. Okay, so it means that this is almost equal to 0 ampere. So this is the characteristic of the diode that now my pen started to write, so I can give you some overview about the diode. Okay, so this is a diode. Sorry, this is negative side. This cannot start. This is negative side. Okay, so what happens when you give it a voltage supply of positive here and then negative here? Then conduction will start. Current will start to flow from here. So this will be forward biased. Okay, so if you draw its curve, so in case of silicon, until the threshold, this has a threshold voltage of 0.7 volt. Until 0.7 volt is achieved, there will be no conduction across the diode. When 0.7, for example, here 0, 0.2 up to 0.7, from 0.7 the conduction will start. Then current will start. This is current, this is voltage. Okay, after 0.7 the diode will start to conduct. Okay, do you get this point? Now you can check this same behavior here, that now this value of voltage is 0.2 volt. You know that 0.199 millivolt is, if you shift the decimal here, so this is 199 millivolt, it means 0.19 volt. So until 0.7 is achieved, there will be no conduction. Current will always be equal to almost 0 value. Clear? This point is clear? This is very important.
Yes.
Okay. Yes. So then, now let's increase, clear all my drawings. So let's increase the voltage now to 0.3 volt. At 0.3, check. There is a little rise in current. Now it becomes microampere, but still it is very, very less value. How much is it? 0.00004 ampere. And then now this is 0.3 volt. 299 millivolt means 0.3 volt. Okay, clear? Then I will write this value for, okay, there is no 0.3. For 0.4 we will write. So we will increase it to 0.4. Okay. My bar is now up. .4 volt. You don't have to run the simulation again and again. Only one time you will run it. Just changing this bar, you will get the value. Okay, now for 0.4 volt, how much is the current? 33 microampere. And how much is the voltage? 0.396, almost 0.4 volt. Okay, you will write that value here. Okay, then how much? You will increase it to 0.5 volt. 0.5 volt. Now check. Your current is 0.201 microampere and your voltage is 0.4 volt. You will write this value here. Similarly, you will increase it until 2 volt, and then but one more thing here you will check. Now the current will start to rise from the value of micro to milli. Okay, let me make it 0.6 volt. Now 0.7 volt. At 0.7 volt, check that this is now milliampere. Before at 0.6 it is still micro, but now at 0.7 this is a little bit rise in the current value. This is now 1 milliampere. It means that 0.001 ampere. A little rise in current starts. Now it means that conduction has started. Okay, then you will increase it to 0.8. Then you will see that I have already filled this table. Then you will see that now my voltage is 0.589. Just 1 minute. Hello. Hi, how are you? Good, fine. Yes. Sorry. So, okay. Now I will change the value of the voltage from 0.7 to 0.8, and then I will see now my current is rising. How much is the current now in ampere? Can anyone tell me? If I can increase it. Tell me how much is the value of current here in ampere. Now this is 2.103 milliampere. How much is it in ampere? Can anyone tell me?
We multiply it with 10 power of minus 3. It will be 0.002.
Yes, exactly. Multiply with 10 raised to the power 3, positive 3, not negative 3. You will multiply it with 1000 or 10 raised to the power 3. It will be 0.002 ampere. So now you see the current is gradually it start to rise. Okay. Then you will increase, and then until 2 you will increase the value, and then you will get the value of current. Now you have this table. Okay. What is your next step? I need the graph for the forward bias and for the reverse. Now you will just copy these values, these two columns only. You will copy these two columns here. Okay, and then you will open Excel. Okay, I have already done it. Okay. So you will go to Excel. Okay, then you will paste that value here. Okay. Now one more thing is I will straight away multiply this column with 1000. Okay. I pasted the formula here. I will just, because it is 0.199, I will multiply it 10 raised to the power minus 3, or I will divide it with 1000. It's the same thing. So, for example, 99.95. If I multiply it with 10 to the power minus 3, it will give me 0.199 volt. Okay, right? Because this is milli. You remember the unit for this was milli. Milli. All these voltages in millivolt. Milli means 10 raised to the power minus 3. Multiply this column with 10 raised to the power minus 3. It will give you these values. Okay. I just use the formula, but you can manually multiply it. Then here, this is nano. Okay. So this is 518.49. It is difficult to write here. Let me write here. 519.499 nanoampere. Nano means 10 raised to the power minus 9. If you shift the decimal point, 1, 2, 3, these are 3, 0.0003, 0003, and then 519. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10 raised to the power 9. So nano will disappear and then this value will come. I wrote this value here. Do you get it? So this is a, yeah. This is micro. Can anyone tell me how I will convert this micro into ampere? Now all these values are in ampere. All these values are in ampere.
10 minus 6.
Yes, exactly. Multiply with 10 raised to the power minus 6. Actually, positive 6 will shift it or shift it like this. Then all of these values, so this is milli, you will multiply with 10 raised to the power minus 3. Okay, positive 3. Then you will get all these values. Okay, then the next step is, let me clear all the drawings. Okay. Then you will choose these two columns. Okay. Then you will come here, insert. Here, this graph you will choose. See, I got a new graph here. Okay. Then you can see clearly that this is your voltage until 0.6 volt. There is no, a little conduction will start at 0.6 and then exponentially increase at 0.7. Okay. So this is the forward bias characteristics of diode. Now one more thing, you will click here, you will add title, and then if you click the graph, there is a plus sign here. You will choose from here axis. You will write here, which axis is this one on the vertical side? Anyone tell me? Anyone tell me which axis is this? What is the value? What is rising across the diode? Current is rising.
Current.
So this is diode current. ID and value is in ampere. Okay. So right. And then here, what is this? What we are increasing across the diode?
The voltage.
Voltage. Very good. So this is diode voltage and value. What is the unit? VD, because we have converted it from millivolt to volt. So this is volt. Okay. Okay. Then here you will write what is this? Which characteristics are these? Diode forward characteristics. Right? Spelling is not correct. Diode forward characteristics. You will just copy this graph from here, or you know this tool in snipping tool, SNIPPING snipping tool. You will click this and then from here just take screenshot like this, or and then here this will come here, snipping tool. So this comes here. If you click it, copy and then you will paste it here. Okay, you can delete this one and then you can just put here and then write forward characteristics. Your graph is here. Or instead of the snipping tool, you can directly copy from here. So this one I delete because I already have this graph. Copy and go. So from here, which part?
No, I can't find the report in the model.
I will upload it. I will upload it. I will upload the lab exercise so that in the next class you will bring it with you with this solved pre-lab.
Also, we won't continue today.
Yes, I will upload it. I didn't yet upload it. So Control C and then you will go here. Here you will paste it. Good. Then the next step. Now we are done with this first table and first part of the lab. Now the next is reverse bias characteristics. What we have to do? We have to just flip this diode and then okay, here I will come back here. I will just delete this. Okay, I have to stop the simulation. Okay, and then I will flip it vertically and then I will connect it here. So I told you what will happen in the reverse biased mode. Until a threshold, until a breakdown voltage of diode is achieved, there will be no conduction in the reverse biased mode. So we will start to, okay. One more thing. Here I will increase the voltage to 1500 volt. Okay. Or I will go exactly with this one. Okay. I will give the negative voltage. Okay. So I will start from 0. So now no need. So minimum value should be minus. Sorry. So, okay. So how much is the minimum value according to the sheet? -2. So make here minimum value -2. And then we will start, okay, make it 5, but we will start it from 0. We will start from 0. So, okay. From here, we will start. It was better that I could directly choose it 0. Let me directly choose it 0. So at 0, I will run the simulation now. So there is 0 ampere and 0 volt. I will come back to my sheet. I will write the values here. Then I will decrement it to which value? 0.2. 0.2. How much is the value? -498.72 nanoampere. It means almost 0 current. And then -0.2 millivolt. Okay. Now we are going to the other side of the axis. Okay. Similarly, you will decrease it to -2 volt and then you will get the values. Okay. Then finally, you will come back here. The same way you will choose those 2 columns here and then you will shift the decimals by multiplication with the factor and then you will plot here the reverse biased characteristics. Okay. Then you will plot a graph. The graph will come like this. So this, for example, the forward bias characteristics of diode are like this and reverse bias will be like this. Okay, your graph should be like this. They will be separate, but the reverse graph will look like this. The forward graph will be like this, as it is shown here. This is forward, this is reverse. Okay, so these two graphs, you will bring them with you in the next lab. And then this is the hardware part, which we will start in the next lab, when you will bring your pre-lab with you with the graphs, and then we will solve the same experiment in the hardware, and we will bring out these two graphs using the NILBIS board. Okay? Clear?
Yes.
Here, Miss.
So I will upload this lab sheet on the Moodle now. Try to solve the reverse biased characteristics yourself and try to build the graph. And if you have any problems, you can just email me. I will tell you how to do it. But I think you will be able to do it. Only you just have to give these values, exactly these values, and then you will, similar way, you will get some voltage. And then do take care of the negative sign. Don't remove the sign so that you will get the values. So you will get a graph exactly like this. Exactly like this. Okay. So you will copy that graph. You will paste it here, just down here. And then you will bring it for your next lab exercise. Okay. Clear? And these slides, if you need, I can upload, but they have the solution. I will just upload the lab sheet, and I will upload this today introductory video also, so that you can take your reference from here. Okay? Anything you want to ask me? Or what we can do is still have 1 hour. It's better that you can do this reverse characteristics with me now. I am here for 1 hour and I want to see your graph. This. Okay, I will also start to prepare this graph, and please work with me for the negative because we still have 1 hour. Okay.
I already done the circuit, Miss.
Okay, so have you filled this table also?
No, I'm waiting.
No,
you
no.
to
Okay,
it's
I
in the
upload this now.
negative.
Yes, yes. I upload this now. Okay, so that you have this with you. Okay, delete. Okay. This. And this values I will delete. Okay. I have to do it in my another. Yes. I'll just one little bit, just 10 minutes. So okay, actually I need some time to upload this exercise because I have to write your name column also. So it's better, okay, I will upload it, and then if you have any questions you can ask me, but please bring this pre-lab before next lab, okay, so that we can directly start the hardware instead of doing this simulation again with you. I will not do any simulation during the lab, okay. Always I will upload this pre-lab and lab exercise for the experiment on the Moodle. Please, before coming to the lab, check that and try to do all the simulations yourself, because in the lab we will only do the hardware. Okay?
Okay,
Right?
doctor. So next Monday we will do hardware. And then
Yes,
when do we
indeed.
have to submit this report?
Yes. So come to the lab, and then we will try to only solve the hardware experiment. And I will upload this now in the Moodle, and so that in the next class you will come with the graphs, these two graphs. Okay?
Miss, I mean, when is the submission?
No submission this week.
Yeah,
Next
I
week
mean,
only.
yeah, next week. So we only have 3 days after
3
that
days.
lab.
3 days.
Only
yes.
3 days.
3 days.
Okay.
Yes.
Okay.
Yes.
Okay. Thank
It
you.
will be enough. It was the same for 101 also. Okay?
Miss 101, I think we had one whole week.
No. I never gave you 1 week. Only in the last experiment, lab number 6, I gave you, that was AC. But for the rest, I never gave you 1 week. I remember.
Okay.
3
Okay.
days.
Thank you.
3 days. So, okay. Now, just in 10 minutes, I will upload this lab first exercise. And inshallah, see you next week in the lab, in campus.
Inshallah, Miss.
Okay. So take care and have a nice day. Bye-bye.
Bye, doctor.
Bye-bye.